Okay, so first I will define what is logarithmic series. So logarithmic series means and binomial series. So the Maclaurin series of log 1 plus x is equal to x minus x square by 2 plus x cubed by 3 minus x raised to 4 by 4, etc. And this is valid when minus 1 less than x less than 1. So now we can derive this. So here given, so we can find the Maclaurin series of log 1 plus x. So we will take f of x equal to log 1 plus x. Then we know that we know Maclaurin series is f of x equal to sigma k equal to 0 to infinity f nth derivative of 0 divided by n factorial, sorry, k factorial, kth derivative of 0 divided by k factorial x raised to. So this is actually equal to f of 0 plus f dash of 0 by 1 factorial x plus etc. And so here f of x equal to log 1 plus x. Therefore, f of 0 is equal to log 1 which is equal to 0. Similarly, f dash of x is equal to derivative of log x. Log 1 plus x is 1 by 1 plus x, and f dash of 0 is equal to 1. Similarly, f double dash of x is equal to minus 1 by 1 plus x all square. Again, f double dash of 0 is equal to, if I put x equal to 0 here, it is minus 1. So, continuing like this, we will get f triple dash of x is equal to minus 1 is a into minus 2 divided by 1 plus x all cube. So 1 by 1 plus x square or derivative is minus 2 by 1 plus x all cube. So minus 1 into minus 2 is actually 2. 2, or we can write 1 into 2 is 2 factorial, right? So f triple dash of x is equal to 2 factorial minus, okay, minus minus plus. Similarly, f fourth derivative of x is minus 1 into minus 2, you can take outside, into derivative of 1 by 1 plus x all cube, that is equal to minus 3 divided by 1 plus x all raised to 4. So you will get f fourth derivative of x is equal to 0 is equal to, sorry, here 0, minus 1 into minus 2 into minus 3, which is equal to minus 3 factorial divided by 1. So continuing like this, you will get f fifth derivative of 0 is minus plus 4 factorial. F sixth derivative of 0 is minus 5 factorial, etc. Now, if we apply this in this Maclaurin series, therefore Maclaurin series of log 1 plus x, Maclaurin series of log 1 plus x is equal to, okay, so f of 0 is 0 plus f dash of 0 1, 1 by 1 factorial x plus f double dash of 0 minus 1 by 2 factorial x square plus f triple dash of 0, 2 factorial divided by 3 factorial into x cube plus f fourth derivative of 0 minus 3 factorial divided by 4 factorial x raised to 4 plus etc, right? So therefore log 1 plus x is x minus x square by 2. 2 factorial is 2 plus 3 factorial, 2 factorial and 3 factorial get cancelled and you will get 3 plus x cube by 3 minus this will become 4 minus x raised to 4 by 4 plus etc. So that is the Maclaurin series of log 1 plus x. Okay. So if I get log 1 plus x, then I can find, okay, what will be log 1 minus x. Can you guess that? So already we know log 1 plus x is equal to x minus x square by 2 plus x cube by 3 minus x raised to 4 by 4 plus etc. Then what will be Maclaurin series of log minus 1 minus x? Anybody? By 2
So minus x square by 2 minus x cube by 3.
Okay, so that means we will replace x by minus x, right? This is actually equal to 1 plus minus x. So from in this equation, we will replace x by minus x. So this is equal to minus x plus minus x minus minus x all square by 2 plus minus x all cube by 3 plus minus x all raised to 4 by 4 plus etc. So our therefore log 1 minus x is equal to here minus x square by 2 so minus x square by 2 minus x cube by 3 plus etc. Sorry, minus etc. So this is the Maclaurin series of 1 minus x. Okay. Now how to find out this log 1 plus x divided by 1 minus x? This equation. Anybody have any idea? Already we
Log
know.
1 plus x minus log 1 minus x.
Okay, good. So that means we know that log a by b is equal to log a minus log b. And also we know that log 1 plus x is equal to x minus x square by 2 plus x cube by 3 minus x raised to 4 by 4 plus etc. And also we know that log 1 minus x is equal to minus x square by 2 minus x cube by 3 minus x raised to 4 by 4 minus x. Therefore, log 1 plus x divided by 1 minus x is equal to we know that log a by b is log a minus log b. So, log 1 plus x minus log 1 minus x. So, this is actually is equal to x minus x square by 2 plus x cube by 3 minus x raised to 4 by 4 plus etc. The series minus x mm, minus x square by 2 plus minus x cube by 3 minus etc. So here we will get x and here minus x, that means 2x, and here minus x by 2 minus plus x square by 2. So this and this get cancelled and we will get plus x cube by 3 minus plus. So this is x cube 2 times x cube by 3. Similarly, you will get x raised to 5 by 5 plus etc. So this is the series expansion of logarithmic expansion. Now, we will move to, so these are the logarithmic expansion. So now we will move to another topic that is binomial series expansion. You already know what is binomial series. For the case 1 plus x all raised to m. So first we will define if m is any real number. So this is valid for m is any real number. Then the Maclaurin series expansion of 1 plus x all raised to m is called binomial series. So the Maclaurin series expansion of 1 plus x all raised to m is called binomial series. So here we will do that. So we have f of x is equal to 1 plus x all raised to m. Then what will be the Maclaurin series? 1 plus x all raised to m is equal to, we know that sigma k equal to 0 to infinity f kth derivative of 0 by k factorial x raised to k. So now first we will find out f of 0. Sorry, f of x is 1 plus x all raised to m, which implies f of 0 is equal to 1. And f dash of x is equal to actually derivative of 1 plus x all raised to m into 1 plus x all raised to m minus 1, which implies f dash of 0 is equal to 1. Sorry, m. If I put here 0 and then 1 raised to. So f double dash of x is equal to again derivative of this m into m minus 1 x plus 1 all raised to m minus 2. So f double dash of 0 is equal to m into m minus 1. So if I continue like this, f kth derivative of x is equal to m into m minus 1 into m minus 2 into etc. into m minus minus of this, like m minus minus of k minus 1, that is m minus k minus of 1 minus of minus 1 plus 1 x raised to m minus k minus k m minus k. So f kth derivative of 0 is m into m minus 1 into m minus 2 into etc. m minus k. So if we put in this equation, you will get S binomial series expansion Maclaurin series 1 plus mx plus m into m minus 1 by 2 factorial x square m into m minus 1 into m minus 2 by 3 factorial x cube etc. Okay. So suppose m is a non-negative integer. That means m is of the form like 3, 10, 100, etc. That means a non-negative integer. Non-negative integer means positive integer like 2, 3, 4, 5, 1, 2, 3, 4, 5, etc. So if m is any number, we know that if I take m equal to 6, we know that m plus 1 is equal to 7, right? Seventh derivative. So then sixth derivative of, okay, f of x equal to 1 plus x all raised to 6. Then what will be the seventh derivative of this function? Anybody? F of x equal to 1 plus x all raised to 6. Then what will be its seventh derivative? Anybody? What will be its first? Okay, if you have a confusion, then we will take. What will be the first derivative? If I have 1 plus x all square, f of x, then what will be f third derivative of x? First derivative of x is 2 into 1 plus x. Second derivative of x is 2 into 1 plus x derivative 2. Third derivative must be derivative of 2 0. So third derivative must be 0. That means 1 plus x all square. Then third derivative must be equal to 0. Similarly, here if we have m integer, non-negative integer, then all derivative f raised to m plus 1, f in m plus 1th derivative of 0 is equal to f m plus 2th derivative of 0, etc. is equal to 0. So after this particular term, all terms become 0. So what will be the binomial series? We will get a polynomial. 1 plus x all raised to m is equal to 1 plus mx plus m into m minus 1 by 2 factorial x square plus m into m minus 1 into m minus 2 divided by 3 factorial into x cube, etc. x raised to m. Okay. And this is valid for any x in between minus infinity and infinity. Now, it can be proved that if m is not a non-negative integer, that means if m is a negative integer, then binomial series converges to 1 plus x all raised to m if mod x less than 1. That means if mod x less than 1, mod x less than 1, 1 plus x all raised to m. So that means for all raised to m may be any non-negative, any negative integer. Okay. Then its expansion can be written as 1 plus x mx plus m into m into m minus 1 by 2 factorial x square m into m minus 1 into etc. m minus k plus 1 by k factorial x square. And this is valid when mod x less than 1. So this you can easily prove by using you already studied these convergence of series. So if you put any value m less than 1 and mod x less than 1, you can easily find the series converges. So this is called a binomial series. 1 plus x all raised to m equal to 1 plus sigma k equal to 1 to infinity m into m minus 1 into m minus k plus 1 by k factorial all raised to x. And this is valid only when mod x less than 1. So that is binomial. So you have to study this binomial series. So we will do this problem, two problems, and we will conclude the session. So first question is find the binomial series of 1 by 1 plus x all square. So so we know that since the general term of binomial series is complicated, we will write the series in the pattern. Okay, as in the formula. So here m is equal to minus 2, right? So we can write 1 by 1 plus x all square is equal to 1 plus x raised to minus 1 minus 2. So we know that the binomial series expansion 1 plus x all raised to m is 1 plus mx plus m into m minus 1 by 2 factorial x square plus m into m minus 1 by 2 into m minus 2 by 3 factorial into x cube plus etc. So here we will apply that 1 plus minus 2x minus 2 into minus 3 by 2 factorial x square plus minus 2 into minus 3 minus 4 by 3 factorial x cube etc. So if you simplify this, you will get the answer as 1 minus 2x plus 3x square minus 4x cube plus etc. So this is very important binomial series, that is 1 plus x all raised to minus 2 is always equal to 1 minus 2x plus 3x square minus 4x cube plus etc. Similarly, you can find this series. You just apply this here m equal to minus 1 by 2. If I substitute in the equation, we will get the series expansion as like this. So these are your exercise problems to this problem. Okay, so these are your exercise problem. and you do this problem and um, submit in Google Classroom. So I will send you these questions in your WhatsApp group. Okay. So okay. So if you have any doubt, you can ask me. Otherwise, we can conclude. Kind up. Anybody have any question? I think time is. So tell me, anybody have any doubt?
No, sir.
Okay, it's clear, right? So next class we will start Fourier series. Next week we will complete Fourier series. Okay, that is the fifth module. Fourier series examination. Most probably module 4 and 5 will come. Okay, so I will inform you later. So thank you.